Hello everyone, welcome to this tutorial where we learn how to work with database in Go. At the moment I have my IDE open. I only have this main.go with hello world on the screen. There is nothing special about that. And I have my Golang IDE connected to my database. I have one database here called YouTube that I'll be using for all my tables and all that. I'm using Postgres SQL, Postgres 14 to be specific. I have it running on the Mac. If you don't have Postgres currently installed on your system, please go to Google, type how to install Postgres for your own operating system, and we can take it up from there. All right. First thing I want to do is to create a connection to the database. So I will say connect to DB. We need the data source name or the string that we need to use to connect to the database. This function will return sql.db and a potential error. To connect to the database, you need the database library itself. So if we are going to use Postgres, you need a Postgres implementation of that single API. The Go provides a single interface for relational database management systems. So basically what we are going to use here, we are going to use a Postgres version of that implementation, and then that would enable us communicate with Postgres. So what I'm going to do is to go ahead and install that library from GitHub. I'll type go get github.com/lib/pq, and this should give us the latest version of that library. Right? Why that is installing? Because my internet is quite slow. Great, it's installed. All right, so first thing I'm going to do is open connection to the database. I will go and say, I'll name it DB and potential error. Almost everything returns an error. So I will say sql.open, where our driver is going to be Postgres. So if you're using MySQL, it will have to be your own the SQL driver. Then we pass in our data source name. If we have an error, you know the drill. If you've been programming in Go, this is how you do error handling. After that, we also want to attempt a ping, which we can do db.ping. And if we have an error, we return it as well. Else, at this point, we can return this. I'm no longer returning it. I want to return the DB instance and nil at this point. This is how to connect to the database. Very simple. At this point, we can come here and we want to put the data source. I'll come back to fill that out. Then let's call it this DB error, connect DB, passing the data source. If we have an error, we want to log failure. At this point, we can exit the program because there's nothing else we can do when we run into an error at this point, right? So far, so good. In order to set this DSN, which is basically the connection string to Postgres, I can type it in here directly, but I'm going to set an environmental variable. Or just for the sake of tutorial, we can go ahead and type it there. So I'll type Postgres, : my username is Postgres, my password is Postgres, it's running on my local host on the default port, and I want to use the YouTube database. I also want to set some flag here by turning off the SSL mode on my local development. This is straightforward. At this point, if we do have a connection, I think we can just ignore this for now. I'll come back to it later. Let's print out something that shows that we go past that error. That means we're connected to the database and we are free to start interacting with it. So I'll say connected to DB. At this point, I'll run go, run main, and then hopefully we see connected to database, and nope, we didn't see that. It's saying SQL unknown driver Postgres. Yes, because we need to import GitHub, the library. Don't forget the library downloaded. We need to install it. Sorry, we need to import it. And now we are connected to DB. Fantastic. So far, so good. All right. The next step is to create some tables, and then we can start interacting with those tables. So I'll go ahead and let me put out all the tables in the file called sql.sql or tables.sql. And then we can start working on them. The first table I want to create is create a table called users, create table. If not exist, I like to add this clause so that I don't mistakenly cause an error or truncate data. And put a auto-generated non-primary key, which is called ID. Just have a name of type text, not null. I can also have email text, not null as well. I have created that, which I'll make timestamp, and I will do it with time zone, not null. Default would be now. I'll keep it this simple for the start. What I want to do is to execute it against my database. You can run it. In short, one way to do it is to run it from Go. So why don't we do that? So I'll just name it Q, paste it right here. And I will do, let me see, results. So we have access to, let's turn on the DB here. When you do DB dot, you see you have query role, you have just query, the two general purpose query have execute and all that. So if we want, we can use this execute, pass Q, and it returns what? You see that it returns an error and a result. So we can do raise error, and we check for the error. Result has some information like last inserted ID, affected rows, and all that. So we can just ignore this for now. I don't think we need it for anything. Since we are not creating a new variable on the left, we can take out the colon to just set the error to this result here. So this is what I have. I just keep it that way, and let's run it and check if we have the table created. Running, great, it ran without any error. So we go to, I would refresh my database and tables. Yeah. Yes, we have users created. Fantastic. You see that these are the columns that we have. So as you can see, we are already interacting with the database. So this is what it is. I'll go ahead and take it off, and we can restore this back to what it was. But I want to now start working on the model itself, on how we can insert data, fetch data, and all that. So I'll create a model directory. It doesn't have to be model. You can name it anything you like. But I have a users file at this point. I will define the struct for user. Say user struct. We have an ID, which I will make as int64. We have a name. We have an email. Both of them are string. And I think, then they created that. Created that will be time.time. Looks good to me. So we have these 1, 2, 3, 4 fields to match our database layout. And we are going to create another type here called user models. I'm going to pluralize it. And then struct. That will have a dependency to sql.db. The reason why I'm doing this is because I need a way to pass on the dependency. So for example, when I come to the main, I want to have, let's say, user model will be users model, and I want to be able to do DB and pass in the DB, which is the one that we're going to expose here. From there, I want to be able to say create user. So I say there's a user that we want to create or something like that. Let's say we want to create a user. We can say var let's make it like this, a user, and then user. Let's set the name for the user, Abba, email, Abba at example. I think that's about it. Then I want to do my user model dot, which at this point should return an error. You see everything I'm doing, we're going to go and write a code to make it work. So this is sort of, I don't know, maybe you can imagine it like not necessarily test-driven development, but a way to sort of start with the end goal in mind. So I can say the user model dot insert, and I would pass the reference to that user. And when we are done, we just check for error, for instance. If everything goes right, we should be able to say, for instance, printed created user with ID, and then I want to pass user.id, and we should have the ID of the last user created. At the moment, if we try to run this code, it's going to fail, which is normal because we do not have the insert defined yet, right? We can have it defined for us by using the IntelliJ helper, and I've just named this U. And this is the user model. We can accept non-pointer because we're not changing anything internally, and we can leave it that way. And we'll go ahead and start typing out the SQL, which I will name as Q, which will be insert into users. We want to insert into users the name, the email. We created that as a default timestamp, so we don't need to do anything there. Values will be 1 and 2. If you are using MySQL, this needs to be question mark. So, and when we're done with that, I want to return the ID, and I guess created that because we do not pass that as part of what we initially used to create a user. All right, so I'll leave it that way. Then I can say row or error would be, another way, if I don't want to save it, look at what I'm going to do. I'll say return m.db.query row, right? I'll pass this. I also need to pass in, let's say user dot, the name first, user dot email, then we scan, and we're going to scan back the returned data, which is ID. So this is our user ID, and u.created that should have our returned data. If everything goes right, we should have our user in the database. Very simple, almost just 2 lines of code or thereabout, and we have it. Now let's go to main to see if our code now looks good. No more error highlighting, so we can go ahead and run the program and see if we have done everything correctly. We should have created user with ID of 1. I can go ahead and insert a new line character here and run the code again, but this time around I'll change it to Mary, and I would change it to Mary and Joseph. Interesting idea. Great, created user with ID of 2. You see our code works. Just to confirm it, one more double check, I'll go to hop into the console, which I can type SQL directly and run the code, and we should see 2 rows in our database. Works great. All right. Coming back to main, we want to look at next thing to do. Now we have the user, inserting of the user. How about returning the user? So we want to be able to return all the data of the user. Taking same approach, I will want to do it like this: users error UN, which is the user model. Let's say get all, and I like to check for errors. If there are no errors, I want to be able to do for user range users, and let me bring in my print here, and I would say ID and ID. I just put the ID, put colon, the name, and the email, and I would that would be user.id. Since there's nothing there, that's why we're not getting syntax highlighting box. So user.id, user.name, user.email, and I think this is what we want. At the moment, it's not going to work. So we need to go and add this method again and create the method. So this is the method on the user's model, right? So let's go back and start to make it work. We return a slice of users, right? And also an error. Okay. We can define users of type users and return it users and name, just to satisfy the code. If you go back to main, everything should look good, and when we run the code, I don't think we should see an error. But of course, we are going to recreate this user one more time, but it's no problem. But there are no errors. So let's go and finish the implementation. All right. So what I'm going to do is to write out the SQL again, which is relatively simple, which I'm going to say select. This time around, I'm going to name the field ID, name, email, created at from users, right? This is what we want. Then we are going to, so if you go to M, if you access this M and this DB object there, you would see that we have query, which can do general query. Basically, it can do anything, query and return rows and errors. So we're going to need rows error will be equal to this at query Q. Since we don't have any parameter, we can leave it that way. One interesting thing is if you want to do with context, you can do query with context. Query. Then they have query context. That one, you can pass context and do some cancellation if you want to do that. But let's keep it simple. This is a tutorial. I don't want the video to be too long, so I'll check for error again. If there are errors, we can return nil and the error. Great. Now we have rows. Basically, we need to scan. So we can say for row.next, that means if we have more rows to access, continue looping, right? Then we need to create a user internally here that we are going to scan the data into, then we append to this slice that we have. So what I'm going to do now is rows.scan. The destination, this returns an error, so let's not forget to set it. Since we have an error somewhere at the top, we can just do this. So the first data we need to scan out is the ID, so it will be user.id. We also need the user.name. Don't forget that you are passing the pointer user.email, because we have the ampersand here, and then the created at, which is the user.created at. That's it. And we check for error. Very good way of doing things. If error is not nil, we return the return name and the error, exactly like what we have here. After this, we want to say users equal to append users, and we just append the user at this point. And that is it. One more thing you need to do is to say error equal to rows.error. So if you do have any error during the scanning process, you need to also check for that. Until then, you won't be able to, you shouldn't return. Always do this, right? Some people skip this path, and I don't know why, but always do this. I think there's a way to make this code one-liner by saying this error equal to this, and if error equal to why is it okay? I see why. Yeah, so make it one. This is just simplified. Great. Time to run the code now and see what we have. So you see, we have the user created the third time because we just left the code there, but you see that our get all method is working. We have the 1, 2, 3, and 4. Fantastic. So this code works, but it's returning all the data. What I want to do is to go to main and make this insert function a little bit crazier. Instead of doing this, I want to, let's change this a little bit. I is equal to 0, I less than 100, I plus plus. Bring this code into this place, and I'll say, instead of Mary, I will say printf sd. I'll just say I, and then user 1, user 2. Email would be, I think I can leave the email. We don't need the, okay, no problem. Let's just, to avoid some laziness, let's make it user d at example.com, and then make it I. That gives us the user, and we can go ahead and create 100 users right away. Run it. You see, I have user defined somewhere, and I do not have it. Yeah. So let's run it again. Great. We have all the users created. I want to run it one more time because I have enough users. Great. I'm going to delete that code right away. It's doing too much. So go ahead and run it again. You see that we have 204 users all returning at once, which is somehow not good. So what we want to do now is to how to paginate results. Already you have seen how to fetch the data, how to create the data. Now let's add some pagination to this method. The way I'm thinking about this is to accept something called a filter. So let's go to model, and I want to create a filter, and type filter. There's nothing special about this filter. I just want to make sure that it is what we use to configure the offset and limit and all that. So I want to come here now and say filter. Alright, that way this code is going to break, so I need to create a filter instance here. F, let's say filter. Exactly, and then I'll pass the F to it. At the moment, code should continue to work, no problems. Right, code is still working as expected. Now let's work on the filter a little bit. We need the page and the page size. Both of them int. Right, both of them int, page and page size. When we're returning the data, we also need to return metadata like the total number of records, the current total number of items on the page and all that. We need to return that as part of it. So let's go ahead and define another data type here called metadata. And I can just say we need a current page size, for the first page number. We're going to need a last page number, total record, or will be of type int. Filter, I need to, let me add some two methods to help us. Just the limit, that return limit, and I will say the limit is f.page size. Return f.page size. And this needs to be int. That works. I'm going to copy and paste it, and I'll name this one offset. And offset will be just done with the little map, page -1. We now multiply it by f.page size. Alright, that's it. Next thing is to calculate this metadata, which is really simple. Let's say compute metadata. What do we need? We need the total record. We need the total record, the page size. All of it is int, and then we return and destruct from this compute. I think we have an error here. Typo compute. Well, I'm typing in caps. Compute. What is wrong with my typing today? If total record is 0, we just return an empty struct there. Else we return a struct with some computed values. Current page will be page. We need page size to be page size that we pass in directly. The first page will always be 1. And then last page is more interesting. We need to change this to an int, math.ceil. So inside here, we convert this number to this total records, and we divide it by another float page size. That gives us the total pages, so that we can know the last pages. So the total records would be total record. What else? I think that's about it for this. Next thing is to go to our model and add some limit, which is basic SQL way of doing things. Nothing special here. I want to bring this now to a new line. Just bring them to a new line. And I'll say limit. This is 1. We don't have any place for that, so limit offset will be now 2. Okay. Then what next? Since we have that, we need to now bring dot limit filter. We're passing that filter dot limit, and then filter dot offset. Okay. And that's it. At this point, we need a way to return the metadata, so I'm going to add another return here for meta. That means we will be forced to return empty meta. When we have an error, we'll be forced to return an empty one. And error. Only at this point, we are going to return meta with something. Let's use the compute meta. How do we get total records? To get total record, we need to find it. Normally, you can do 2 SQL to find the total record, but we have something called window function that helps us do that. So over And that first value will always be the total record. We are going to say var total rec will be int, and I will come here, and that will be the total rec that we have. All the time that gives us the total record, so that is what I'm going to pass here. And pass that there. And the next thing is the page, which we have from filter.page, and the page size, right? And also we need to put a comma here. That looks okay to me. No errors. Let's go to main. With this one now, we also need to get the meta. So for now, let's just put a blank, run it. Great, said nothing. That's interesting, right? Yes, because our page size, let's say our page size is 5. Let's run it again. PG offset must not be negative. Great, so pages has to be 1. Yes, 1 to 5. So we have 5 items. We have about go to page 2. And then you have 6 to 10. Go to page 3. Yes. So if I need to add something like sorting or searching, I'll just go ahead and add them to this filtering, and then this can come from my web interface. The last thing I want to do in this tutorial is to show you how you can turn this into, let's say you are building a small application and you want to use this in your application. So quickly, I'm going to take everything out of my main except the database connection. I'll also come here and define it called application struct, and I'm going to need the model. There's several ways I can do this. So I'll need the user model. So I can say user models will be of type user models. Or let's take this a little bit further. Let's go back into the model and create a models file and define type models struct and say we want this model type. We want this model type in our application, and we want to be able to say users will be users model. What else do we have? I think that's all about it that we have. So that way we can come here and say func. Let's say we want a func new model. That will give us models. We can return models. Return models users will be, we need to initialize the users model will now be db. So we can take the db now as an argument, which is db, which is sql.db. So this is where we do our model initialization. Let's go to main and say models will be of type models. Alright, so that is our app. And then we can say app equal to application, and we'll have models new model, which is something that we have here, and just pass it the db that we have up there. This way we can do anything. Then here I'm going to just say app error equal to app dot since we are putting everything in one folder, I'll just say serve. And if there's any error in serving, I'll return something. Need to add this since we are going to do it in the same space. And I will just say server func app.serve error, and then we can do server http new server, right? Not https, http server. Yeah, this one. I don't know why this one continues to come up. So what do we need? We need to set some things here like handlers. I'll call it mocks. And I can get that from, in short, we can just app.handler. We just return that. We'll come back to that. What else? We need to set the pause address. We need to set the address to, for now, just hard code everything at port 4005. What else can we set? Some timeout read and all that. You can come and set login and everything. So I'm going to just keep it that simple. Since we are here, I'll just add the func application handlers would be HTTP handler. I'll just do mocks would be http.new server mocks or serve mocks, and I'm going to return mocks. Okay, it looks like that is good. Error would be equal to that listing and serve. And if we do have an error, of course, we return the error, else we return nil. One thing I also like to do is to say, go to main and say server is listing on a particular port or that, or just write something like print starting application. Okay, we're already done with the database. I just want to show hopefully some citing thing. So if you want to stop the video, you're good to go. Now, let's run it and see what happens. Actually, go run. Great, starting server. Let me pull out my browser. We are listening on port localhost 4005. Page not found. Great, no problem. We know why, because we've not registered any route. So I'm going to go to the server and I will say mocks.handle func. Let's say when you go to the home page, app.homepage, and I'll come here. And our homepage must be of type. Need to have the signature HTTP response writer and a pointer to http.request. Great. So when you have this, you can write out anything, some bytes. Hello. Let me stop the server, start it again. Bring our window back and run it. Hello, we're good. So you see that our server is working. But we are doing this because I wanted to show you how to assess what we've done here. So we have exposed the model via this application that we have. We have registered the model there. That means when we go to our home page, for instance, we can say, let's say users, or which I want to be able to turn this into a JSON. So I can say users areas app.models.users. I can now do get all. Let's do a fake filter here. I'm going to do filter. Page will be just 1. Page size will be 10. Or let's just make it 20. I'm passing the filter for here. This can come from your query string at the moment. We also need the meta. Right? Now that we have all that, we should, if error is not near, I'm going to just log filter. Honestly, you should return HTTP error at this point, but I'm too lazy to do that. So I will go ahead and just focus on what I want to do. We need to change this into some JSON. So we can do this. Either we change it to a JSON or we write it out that way. So let's go ahead and say for. I think I should change it to a JSON. So let me call it response. Struct will be users. Let me say, which is basically this. And I will say meta will be metadata. Here, inline, we need to now set user to users. Meta to meta. Next step is to write this to as JSON. So JS will be error will be Masha. The data will be res. Okay, so we need to Masha actually. So Masha rs. So it returns what? It returns bytes of slides. So sometimes I get confused on Masha, no problems. So we do that same error, nonsense error handling again. But at this point, we should have the JSON. So I'll go ahead and write header. Header dot. I want to add content dot type application dot JSON. Then write, since we have the data byte slides, we don't need to do anything else. This returns an error, so if you want, you can handle it. Anyhow, looks good to me. Let's run it. We've achieved the goal of, just coming from playing with database. You now have the data on the browser. So you see how we pass it down, basically how we are assessing this by building up a model and then passing it down. One good thing about this is you can change this, for instance, your application at this point. Instead of relying on this new user model, there can be some interface thing going on so that you can mock the whole layer, which is something we're going to see in my next course, what I'm working on how to build APIs in Go. All right, I think this is good. Thank you so much for watching. If you want to turn this to lowercase, just simple thing, let's quickly do that to make sure. Instead of, we can just do JSON, add tag to everything. Because we don't have this in the new line. And this is where my shortcut failed. JSON. Yeah. JSON. Great. And then I think, if there's no idea, then that's no problem. Let's run it one more time to make sure that our code still works. Fantastic. almost starting. Great, we are there, and then everything now looks good. Just by the way, you can see where is the meta? You see the meta path to be current one, page this and that, and you can do some query string to do the pagination. So thank you so much for watching. My name is Joseph Haber. If you've not subscribed to my channel, please, I'm not ashamed to ask, subscribe. Bye for now. Watch out for my course on how to build API with Go. You are going to love it. We'll do authentication. We'll do a whole lot. Talk to AWS and all of those cool stuff.